Liza and I from Hansen Yuncken. Today I'm the project manager for the UTAS Forestry Project. They've recently revealed their new name for the project when it finally does open up, and it's going to be called The Forest. So they've dropped the R and a Y off the end, and that's the new name, which is they're all very excited about. But today I'm just going to present on really the project and how it sort of came to be. We were involved, and some of the things that were really interesting for us right from the start. Some of those key sustainability sort of metrics and sort of goals that were present from the very, very start, and then just some of those initiatives that we've got on site in our journey to the point now where we're about 6 to 8 weeks out from sort of going for PC, and yeah, we're all very, very close and also excited for it to be finished. So without further ado, this is just a sort of a render by Woods Bagot, if you can see that. The dome above is existing, so it's like the one of the newest heritage listed structures in Tasmania. It's built in 1996, and it's pretty much throughout our build we've had to preserve that sort of timber GLT dome above what will become, when we finish, like a fully planted out little miniature Tasmanian rainforest.
Sorry, Alex, can everyone else see the render, or are you just...
Yeah, I was just about to say, I think I'm still on the first slide.
Yes. Yep.
Okay.
Alex, if you stop sharing your screen, then you might be able to.
Nope. It seems to be moving along. Yeah.
Yep.
You can see
We just
that?
went to the second slide. Yep.
Right. So yeah, that's the render, and essentially that's what the view will be when we've, probably more so after about 5 to 10 years of once we've handed over to UTAS. But we have been out to one of the state forests to try and get some of those mature trees. So when we do actually plant them in about a month's time, that impact is there when we do hand over. As I said, some of the things that were appealing for us as Hansen Yuncken when we first sort of got the tender for the forest or the forestry was, it was an ECI engagement. So the university was looking for us to join in and sort of be part of that pre-construction a good 9 to 10 months before we actually started on site. And unlike sort of normal ECIs or early contractor involvements where they usually typically have a real heavy lens on providing staged cost plans and real heavy sort of budget and budgetary sort of advice. This one was a lot more around sort of sustainability, constructability, buildability, how we could sort of really add value to the sort of those aspirations for the university with this project. Very, very strong emphasis on innovation and technology. At the time, and still is, there was a pretty extensive pipeline of work that the university had lined up, circa another $500 million worth of projects, which they really want to apply some of the learnings from this project and sort of just continue that momentum into the sort of the next round of projects that they've got going on. And then lastly, like a very much a strong emphasis on that partnership and collaboration and just working together to try and actually come out with a project that's going to be very, very special when it's finished. So sustainability, as I said, throughout the sort of tender docs we received was just sort of really almost the sort of most prominent aspect of the tender, and something that they were really looking for in a builder to help with this project. And some of those aspirations for them was the project had to deliver on a 40% reduction in embodied carbon versus like a similar sized reference project. Very much looking at that circular economy, dematerialization. A lot of the finishes we've ended up with, they are sort of both the structure and the finish. So we're not going through and applying paint, and we're not sort of having to do those sort of secondary finishes on top of what was the constructed substructure. Adaptive reuse, and that's where we really played quite a significant part in that ECI. They were sort of trying to work out how much of the existing structure was able to be retained, and so the site consisted of as we sort of see in this little render here, two heritage existing buildings that front Melville Street, which is this road here. There was a large sort of 1970s lightweight concrete structure in the middle here of the site, and then there was like an old Freedom furniture at the back. And so as part of our engagement in the ECI, it was really looking to see how much of that existing structure could actually be retained to make the final build that UTAS wanted actually work for them. So yeah, adaptive reuse, obviously big part of the project. In the end, about 3,600 square meters of slab was able to be retained. And then lastly, the project was partially funded through a green bond framework. So funding was secured, but they had to achieve a 20% reduction in embodied carbon for that green bond framework and the finance to actually go through. So, there was actually a lot of pressure on actually achieving those reductions in order for them to be able to fund the project. And so, we're on track still to sort of achieve that 40%, but there is like an LCA carbon assessment to be done at the end of the project to sort of realise what we've done as an as-built. Sort of in that ECI, when we got into it and started getting tender docs, the design team, mass timber was a key element to the whole project. GLT and at the time CLT sort of featured throughout, but the design team wanted to keep it local. They were really interested in getting that sort of warmer hardwood Aussie timber in that structure rather than the sort of pale pine Scandi mass timber. And so trying to keep it local, keep it within Australia was a key for everyone. And whilst we sort of looked at sort of getting it from overseas and actually came to the conclusion that actually, by shipping the timber across from the Scandi countries, it doesn't actually add a huge amount of carbon per square or per cube to the timber. It really came down to more aesthetics for us with the local supply timber. But there was really only probably one supplier in all of Australia at the time, and I think probably still is, that could do a project of this size. So we've got approximately 660 cubes of GLT structure on the project. The timber itself was all sourced from Tasmania through various sort of PEFC certified sources. Our external facade timber fins, the mullions, are also the same GLT sort of format. The primary roof structure and then feature ceiling and cladding throughout also made of timber. And given sort of the quantities and timeframes, sort of Vikash, who ended up supplying the timber, just needed a huge amount of time, one, to sort of culminate all the feedstock required to produce this job, and then also production. So just making sure that they had enough time to produce enough GLT to supply the job once we started construction. And what became very quickly apparent to sort of everyone, that when we sent out the docs to Vikash and started talking to them, was the design we had hadn't been optimized really for manufacture, and effectively they were going to be unable to do it unless we entered into a pretty intensive design phase with Vikash in order to try and optimize that timber structure to suit really their limitations in CNC machines and the various different machinery they have at their factory. So we went over and had people over there just kind of getting an understanding of what those limitations were, and a design manager on site here who just really sort of got in there for a good two months, really a 5-week intensive period, but a good 2 months in an effort to try and optimize the design we had for our mass timber structure, that would suit sort of the parameters and limitations of Vikash. So I've kind of just got a slide here that sort of talks to some of the initial drawings we had and what was being flagged as some of the limitations and issues with that initial set of documents. And then Vikash being sort of a supplier that does this day in, day out, they're pretty used to seeing documents coming through from consultants who may not have a huge amount of experience in documenting mass timber structures, and that was sort of something we experienced here. And you sort of see this is the initial set of drawings that just had really big sort of steel plate connection details, lots of different connection types. So there wasn't a huge amount of consistency amongst the different sort of scenarios we're experiencing on site. And also there was a tendency to really just change everything to timber where they could. So anything that would have traditionally been steel, they were looking for ways to make that timber. So as I said, we kind of got Vikash on board, engaged them under an ECI style contract similar to what we'd been engaged under, and then really went about trying to understand those limitations that existed with Vikash. And a lot of these limitations don't necessarily exist if you go to the sort of the bigger European suppliers of mass timber, but if you do want to keep it local and here in Australia, these are just things that you need to be you need to consider, I guess, when it comes to mass timber. So for someone like Vikash, that if you think of the way they produce mass timber being a factory, a process with like similar to cars, and the timber starts at one end and it's coming out the other end. If at any point you've got a bottleneck in that process, it then causes it to a flow through effect throughout the whole process before it. And so if they're pressing timber and getting this, what they call the blanks, the big solid bits of timber, and that's coming together faster than they're actually getting it through the various CNC machines, that build-up of blanks builds up behind them. And so they're really looking to optimize the pressing to CNC ratio. So essentially, it's all just moving smoothly through their workshop or through the production line. So we had to really understand how much time almost we were allowed in that CNC process. And so things like just limiting the various different types of members. So we went for a process of just rationalizing the sizes to try and get a bit more consistency, trying to get a connection detail that worked in more situations. And then just actually with their machinery on site, we learned that sort of their CNC machine can only do a pass, and they can remove 8 mil of material in any single pass. And then there's also like 150 mil dimension restriction without them having to sort of move and play around with the actual member itself. And so sort of going back and saying to the engineer, if what you had documented as a 10 mil depth of plate or a 10 mil dowel or something like that, if we're able to change it to 8 mil and there's some capacity within your design to change that 10 mil to 8 mil, we can go from 2 passes to 1 pass, or if it was hypothetically 20 mil down to 16, 18 mil, we're able to do it in 2 passes. So just trying to get the number of passes down to get the timber through that production line as quickly as possible. And that was really key for us, is to just was early on to understand what the restrictions in the suppliers' facilities were. So I've got a few slides here which then sort of shows how we progressed through that design and how we really ended up. There you go, some animation, professional. And so as you can see there on the left, the original design, that's what we received at tender stage, of what that mass timber connections looked like. If you can imagine the structure, it's a waffle structure, and you've got these sort of very big loads going through the movement points. These points here, basically moment connections that have huge loads going through them. Some of these beams span 18 meters. It's like 18 meters, 11 meters, 13 meters are sort of three of the kind of common lengths of beams that we've got, and so pretty big loads go through them. This is what we got back from Bikash as by way of I guess a proposal on how to simplify the whole thing. And this is, I guess, what we saw as the gold star in trying to get our engineers, or the engineers on the project, to accept and get across the line in terms of what the design was going to look like. Having worked with the engineers to optimize that design, what we eventually got from the structural engineers is what we call the tender issue here. And so it was still a bit of a hybrid between, I guess, what we had received initially as the original design, and the ECI sort of design from the supplier. But it still just wasn't enough for Vcash to actually make it work and sort of commit to producing all the timber on the project. It was at this point we were really kind of running out of time to try and make it into a production slot for the project, because you still had sort of big steel plates. These screws had to have an element of CNC machined and routing implemented into it, and again, it was just not sort of standardized across the different scenarios that we ended up experiencing on the project. And then with that sort of within the final couple of weeks, we ended up and landed on what is this IFC detail issue here, where some of the elements could get got lightened up, and then we also introduced these dowels essentially that tie it all together. And through this whole process, the other thing that we sort of introduced was, as I said earlier, that there was a tendency from everyone, just because the aspirations of the design team and the university had been, we want a mass timber structure. They just went out and changed everything to timber. And sort of we quickly learned, just because something is sustainable and is a better product, it's not, there's not an infinite amount of it, and it shouldn't just be used willy-nilly because it is that sort of a more sustainable material. And through the introduction of just a small bit of steel here and there, we were able to reduce a huge volume of timber use. So we needed to find the compromise between just like I said, introducing a little bit of steel, and then we saved both money and timber volume. So there is really just a sort of a 3D perspective of what we ended up with in terms of our final sort of structure, as it were. So that's exclusive of the fins and the mullions and a lot of the facade timber, but that's how we integrated the mass timber structure into the overall structure. What you can see there is the stuff in red. That's actually structural steel in the end, and that was originally timber, but by the introduction of the red steel elements, as I said, it just made the whole thing a lot easier to work, and Vikash were able to do it. in this, you can sort of see where the dome sits in this space here. This is that sort of section of like a lightweight 1970s PT slab that sat in the middle. We demolished the roof structure and had just the first floor structure left for us then to build up from with our mass timber structure. And then parts of this back is all existing structure, existing precast structure, facade, where we've modified, removed the roof, put more timber in, modified the facade. But that's sort of where we landed with the mass timber on this project. And then another element that was key to the overall project was the use or extensive use of hempcrete. So when all things are said and done, this will be the largest application of hempcrete in the southern hemisphere. So for those that aren't familiar with hempcrete, essentially it's a mixture of lime, sand, hemp fibers, and water. It gets mixed up, batched, put in a form very much like rammed earth, and then over a 6-week period, it sort of is a chemical reaction. It all calcifies and pretty much gets rock solid. So from the outset, when we first got the ECI documents, the University of Tasmania had expressed an interest in trying to get hempcrete across the line for use on this project. Tassie being probably the largest grower of hemp in Australia, and the university had done a couple of collaborations and experiments with some growers here in Tassie, and so they were keen to try and convert that into actually an industry in itself. But when we first started getting involved in the project, hempcrete hadn't been approved for use on a commercial building, so it didn't have any of the fire or group testing that was required to be used on a project like this. So again, through that ECI phase, we also got involved in commissioning the fire testing, building a room in Victoria, completing that fire testing, and trying to achieve a group rating. Like I said, one of the aspirations for the university was trying to keep it as local as possible, using local materials. And here in Tassie, we are lucky enough to have a wholly female-owned producer of hemp, and the university was keen for us to partner with them just for the supply of hemp on this project. So through that ECI phase of 9 months, we're actually able to convert that process to the point where we had the confidence to specify and use hempcrete on the project. Mastery of a new brackets old trade. There's examples of hempcrete being used in Japan, sort of circa 1100 years ago, which are still standing. And whilst it sort of hasn't been used here in Australia very much, and maybe a few residential builds around the place, it was quite exciting to get an opportunity to use hempcrete here. And again, with that pipeline of work that we knew is coming from UTAS and sort of them expressing an interest in continuing to use that material in future projects, I think we're quite excited to be one of the first to use it and actually master it, and then be able to sort of use that information and IP on future tenders with the university. And it also presented a good opportunity for us to collaborate with the design team and really cement that sort of ethos of working together and collaborating through that ECI phase before we'd even started on site. And then really just to finish before potentially some questions, I've just got a couple of screenshots there of sort of some progress on site, whilst I'm not the best photographer, but they kind of give you an idea of where we're at now on site and how that sort of the mass timber and the hempcrete starting to sort of take form, take its place on site, and actually demonstrates sort of how those initial concepts and renders that we were sort of initially working to are actually starting to look like what they're doing in real life. And then I guess probably just a few other things as I look at this that are probably important for this group is that the other idea for the spaces that was designed and the roof structure itself was, everything had to be sort of freestanding. So what we've ended up building is this what is essentially a large warehouse space barn with the mass timber structure. Which is why it's got such big spans and loads. We've built this big warehouse, and then all of those various little rooms and pods and spaces within it are freestanding, and they've got their own supporting structure, their own, in some cases, sort of mechanical services. And this then gives the university a bit of flexibility if in 20 to 30 years' time they decide to change how they actually provide teaching. And so they go from what is now an average classroom size for the university of around 35, 40 students, and go back to what was 20, 30 years ago, an average class size of 100, 150 plus. They can actually sort of hoard off areas, be working within that hoarded area, sort of changing, adapting these spaces to suit that new teaching style, while still operating the university and providing teaching in spaces that are only sort of 10 to 15 metres away. And so that adaptive reuse of the future has already been considered and how they might adapt these spaces, like I said, if teaching was to change again 20 years' time. And that really is a bit of a snapshot of sort of some of the initiatives we've got on the UTAS Forestry Project. So I've kind of thanks, Eliza, blasted through it, and we've got some time there for questions if anyone has any questions.
Thanks, Alex. That was awesome. Yeah, let's open up to some questions, and I've got a few, but I'll let someone else speak if they'd like. Just chuck your hand up. We'll call on you, and you can ask away. And if there's a deathly silence while people are thinking of what they want to ask, I might go first. Oh, no, Elizabeth.
Hello. Thank you. That was a great presentation. I do have a quick question. So were you aligning to a formal building certification?
So was that?
Were you aligning to or using a sustainability certification or framework?
No, so they've sort of assessed it against Green Star, but aren't necessarily going for Green Star ratings, but more so the sort of the green bond framework and sort of the reduction in embodied carbon just is sort of the driving force really for a lot of the decision making. So at the end of the job, there's a requirement. We are sort of providing EPDs and doing an as-built sort of carbon assessment, but that's predominantly being driven by that sort of green bond framework, but no certification.
Okay. Thank you. And also for the reduction it was only embodied carbon, right? It didn't cover operational carbon.
Body carbon.
Okay.
Yep. Tasmania is quite sort of unique in the sense that actually, because I think it's 99 or 98% of the power generated in Tasmania is hydro, which is sort of typically the single biggest contributor to the operational emissions. The weighting of what's almost more important to consider changes in Tassie. So really trying to reduce the upfront carbon is much more important when constructing in Tassie.
Great. Cool. Thank you.
All right, I might go next. Thanks for talking about that operational aspect in the context of Tasmania. I think that's really interesting to consider because, that's a lot of the reason why MECLA was also born, was a recognition that we were going to get there with operational, and embodied carbon is the next challenge. So it's pretty interesting to see that some of these projects that are emergent are in contexts where that operational challenge is in some sense more solved. And now the embodied question comes to the fore. I was wondering if you could talk, you spoke about the parameters of the green bond financing driving some of these sustainability outcomes. Could you provide a little more detail around how that functioned and how it was set up for the project?
Not really.
Fair enough.
No, I'm not sort of super across, I guess, how it all sort of came to be and what it means. But I just, I know CBA, I think, are the primary sort of financier in the whole thing. And if you search Utah's Green Bond Framework, there's a heap of information that comes up, and the sort of the framework and how it does work, and what bonds had to be issued over what period of time. But I'm in no way an expert in how it all worked in the end.
Fair enough. I'll ask a different one then. With hemp, I'm really curious. You mentioned sort of fire testing and getting a group rating. I'm wondering if there were other sort of specification challenges that you had to work through in integrating the material. And also if you could talk a little bit about its thermal performance, because I think there was a note around thermal performance for the material.
So in terms of certification, really the building surveyor again was put on pretty early in the process and sort of brought along for the journey, and sort of he was probably giving us advice as to what he wanted to see, to give him enough confidence that it could be used on a project. But fundamentally, it was really just achieving a group rating. So we had to get a group rating of 1, I believe, to enable us to use it on this project. And then, so what we ended up having to do, we engaged a company, a laboratory, NATA approved laboratory out of Victoria called Warrington Fire, who had all the equipment required to really give us that group rating, which is all around combustibility. And so we commissioned, they built a room essentially within a larger room. And then they create the sort of source of energy ignition point in the corner of the room that we built out of pure hempcrete. And they're able to test how much energy they put into that ignition source. So it's just really a kind of a jet engine almost in the corner of the room, firing its sort of heat at the wall. And they know that they've put 1,000 megajoules of energy, I think it is, into that fire or that heat source. And because you've got a shroud or a room above the room we've constructed, they're measuring how much energy is coming off of it. And so if that energy coming off of the room we've built is in excess of the energy they've put into the room, they know that the materials are combustible, and that determines what your group rating is. And so when we did it, we built the room. It was all live streamed from Melbourne, and we were here in Tassie, and for 45 minutes we watched probably the most boring live stream ever, where the jet engine just blasted at the hempcrete and nothing actually happened. So after 45 minutes, the heat source was turned off. Over a period of maybe a few minutes, what was a glowing sort of white spot on the wall started to fade, and there was left with a bit of charring, but it hadn't sort of moved any further than when that heat source was hitting. And then, the guys who had conducted the test were able, just without even sort of looking at the data, just were able to pretty much confirm there on the spot that it passed all the tests that it needed to pass and got the top rating. In terms of sort of its performance, like thermally, acoustically, does a great job of controlling the moisture. They're all very high. Doesn't have really any strength to it, so no compressive strength. So you do need to build a framework or a skeleton to support any loads, and it really is just an infill in there. But like I said, it performed really well, and is perfect for being used in where we use it. It's like project rooms and smaller meeting rooms where they want to just obviously control the acoustics and just make them a comfortable place to learn, I suppose.
Some Henry.
Yeah. Thanks, guys. That was really awesome. That's a beautiful building. I love the adaptive future reuse sort of potential with those classrooms inside. I had a question. The hempcrete, you answered about the strength, which I was going to ask, did you have any like workability issues on site? Like you mentioned 6 weeks for it to calcify.
Yeah. No, no. So it's quite interesting. We've got the hempcreters that we've, there wasn't really anyone here in Tasmania, so we've got some that have flown in from Victoria, and they've kind of been here in groups of like 5 to 6 weeks, and they've poured their last wall and are leaving tomorrow. So it's a good milestone. But I think going into the project, hempcrete was going to be one of the ones that I was probably most concerned with, and since day one we've had almost no issues. Interestingly, we placed orders for hemp with a 30% wastage applied to it, which is sort of something typically you would do, with materials you're ordering for construction, somewhere, I don't know, 20 to 30%, and we've ended up with 30% spare. So we haven't there's been zero wastage. And if they have a batch left over from the day before, they just chuck that in with the new batch the following day. So just a very efficient material to use on site as well, which has been great.
Yeah, that's awesome. And I'll just have one more question. The dome, like the timber dome, I might have missed it. Was that reused? And if it's new, was there any is there any like weatherproofing that you've had to do for that, like external application of timber or?
So the dome is existing.
Yeah. Okay.
The dome is existing. This is sort of an actual photo of what it kind of looks like from the inside. And no, the dome's existing. It was constructed in 1996.
Right.
It's actually glazed, so the timber's on the inside,
Okay.
and it's glazed on the outside. Our scope for this was to actually refurbish pretty much the whole timber structure. So it's all been, where there was damaged timber, been repaired. We've sanded it back, oiled it, kind of preserved it, and sort of maintained it for another 20 odd years of use. Some elements of glass were broken, and we've just replaced that. But for the most part, it was in great condition when we took possession.
That's awesome.
Yeah,
It's a great project.
The adaptive reuse component is this would have been built last when they actually did this development in 1996. This would have been the last thing to build, and so for us, working in reverse and that adaptive reuse, trying to work in and around the dome was a challenge, because if we were under a normal building sort of structure, it is also something that we would have built last, given all the works we had to do. And so actually trying to do our work in and around that dome was one of those challenges that we had to sort of work with. All of the supporting structure that kind of goes around the perimeter, at a point in time gets removed and replaced. And so we have like temporary props and things like that in place to maintain it.
That's awesome. Thank you.
And I think Victoria had her hand up, but may have put it down. I'm assuming the question was answered in that conversation. So I'll go to CJ.
Yes, it was. Thank you.
Awesome.
But can I ask something very quickly though?
Oh, please.
I was just going to quickly ask Alex if you know of any other projects where hemp's been used. Did you look at any other precedents or examples, or was this completely new?
At this scale, it was new at the time. There were, quite a few residential buildings sort of around the place, and X-Hemp is the supplier of hemp for this project, the wholly female-owned business that operates out of Tasmania, and they had a couple of examples we could go look at, residential. I think after we'd sort of gone through the process and got the certification and things like that sorted, there is another development in Victoria somewhere where they are starting to use it. But as part of our ECI engagement, we went through the fire rating process and commissioned that test and got the group rating and everything we needed to use it. The university they actually released all of that IP out to the industry and sort of said,
Oh, that was my next
you know,
question.
yeah, they gave it, and sort of it was released to some of the key suppliers and key sort of players within the industry, and said, here's all the data, here's the certification, here's everything you need to be able to use it, and try and sort of increase its use, I guess, throughout Australia. They're sort of hoping that some form of industry, whilst it won't replace, you know, traditional wool types anytime soon, it'd be good for it to grow a little bit.
Thank you.
Thanks for that. I'll just go to CJ.
Yeah, hey, really cool project. I had a question. I know you said you didn't know a whole lot about the green bond, but I'm gonna quiz you a little bit on it. I was wondering if, like, how, because you said there was a 20% requirement for the green bond for embodied carbon reduction. I was wondering, did that flow through? How that flowed through in the contract? Like, did that land in your contract, and like how that risk responsibility framework kind of laid out throughout the project?
Question? No. So actually, none of it wasn't it wasn't. There wasn't a transfer of that risk on to us in the build when they prepared the LCA, or the carbon assessment, based on the as designed documentation. It was showing that it was going to achieve well in excess of the 40%, 47%. And then throughout the process, it was really like when a decision was being made, a design related decision was being made that might result in an element of slab being demolished, because it might have made something else we had to do simpler. You know, there was constantly like sort of checks and balances being done just to sort of see how that was affecting the sort of that percentage. And we never really did anything, or probably tipped it so far as to get anyone worried that we were going to drop down to the 20%. And whilst, you know, we've got 20% sitting there as what the university did need to achieve to ensure the green bond framework could be secured, it's you know, it was never really ever in jeopardy. I also think that in the reference project that they compare against to show that 40% less embodied carbon, they're actually comparing this project to another adaptive reuse project. And so they're kind of actually, there's an element of contingency built into that in itself, that they could probably compare the project to a non-adaptive university style project of the same size. But I think everyone thought that was cheating a little bit, and they were sort of hoping to do better than that. So I think there was never really any risk of sort of getting down to that 20%.
Yeah, that makes sense. As far as the LCA analysis, you said that, you know, there were checks and balances done throughout the project looking at changes. I assume that was that done by an ESD consultant that was on the project, and that was like integrated into that whole. So they'd be checking as these changes came through, just to verify the impact. Okay.
Yeah, more so really through that initial design phase, and the ECI is probably has stopped at a point in time through the construction process, but you know, the changes haven't been significant enough to warrant it. And then at the end of the process now, where we've got to the point where we've got as built, the final sort of recalculations being done by Arabs.
Yeah, sounds good. I was wondering if any of the other partners within this team like use their own in-house carbon tracking just to kind of keep metrics as they went through the project, or if that was just all relied on but into like a ESD consultant handling that whole process.
Yep, ESD.
Yeah. Yep, sounds good. Cool, thank you.
Awesome. Do we have any other questions? Okay.